Excuse me. All right, so today is the 23rd. And I'd like to go into chapter 11. Right? That's what I wanted to do the last couple days. I thought I'd just give you a preview of it early. This chapter 9, I'm simply gonna. All you need to know how to do is to when you click on a button, you're able to open up another form, and the form can be connected to all of the same classes and everything that you create when you create a program. And you've created a bunch of programs in this class, so I'm gonna just have you use those programs to create a multi-form project. So that's going to be simple. But we do have a couple of days. We have 3 or 4 days left. So I'd like to give you a little bit of exposure to databases to try to get you maybe a little bit excited about databases. Because in next semester we're going to be covering databases. Next semester, in this class, we're actually going to be switching over to Python. For 128, we're going to be switching over to Python. And it's going to be, the material is going to be a little bit different. It's going to be more academic focused type stuff. So there's not going to really be any databases next semester in this class. It'll all be you're going to get it all in 148. But I don't see any problem touching on it a little bit in this semester, especially if there's any of you that aren't planning on taking 148 next semester. Although I hope you all do, we can get you all through 128, so you can take 148, and then after you take 148, you can decide whether you want to continue on with programming, or maybe switch over to computer security or something else like that. All right, so I'm going to download the PowerPoint slides for chapter 11. It's chapter 11, and first of all, I'm going to open these up. And the other thing I'm going to do is I'm going to download, go back to resources and go to sample programs, and I'm going to download the chapter 11 sample programs. And the chapter 11 sample programs just give you about like 3 databases or something. Let me just put those on the desktop here. And really it's only three databases. So I'm going to show you how to open up a Visual Studio, create a new Visual Studio application that's got a database in it, and it's real simple. It's easy, and so especially if you follow this video. In fact, I might do that right now. Let me just real quickly do that. So let's open up Visual Studio. Visual Studio. And I'm going to create a new I got to sign in first. Okay, so start a new project, and it's going to be a Windows Forms application. So let me put it down in my my little USB drive here, which would be here and here, and I'm just going to name it Chapter 11 Database. Create new folder, Chapter 11 Database. Select folder. And I'm going to name it, let's name it, which one should we use here? Let's use phone list. Phone list. All right, so so just so we can see what this thing looks like, click on right over here is data sources. If you don't see data sources, you can go to View, Other Windows, Data Sources. And you can click here, Add New Data Source if there's no data sources yet. Click Database, click Data Set, click New Connection. It's an SQL, Microsoft SQL Server Database file. Continue. And we got to find the database, and that was right in up on the desktop. I put it on the desktop in here, right here, this phone list one, phone list MDF, Microsoft database file. And click on OK. And it's going to say something like, oh, it's too old. It's going to, oh, it's not compatible with the current instance of SQL Server. To continue, you must upgrade. Do you want to upgrade? Yes, we do want to upgrade. Click yes. And then it upgrades. And you can look at the connection string. This, you don't need to know about this now, but later on, if you're going to look at some of the applications in the book, you might notice that they use a different kind of database. We're using this local DB MSSQL, local DB database, and so on. Anyway, click next, and it says it's not in the local, it's not a local data file in the project. In other words, you don't see it over here on the right. So click yes to copy it over onto the window on the right. And now you see it there, right here. So now click next. And now we need to decide what out of this database we want to include. And so click down on tables, click down, there's only one table in here, and it's called a person table. And I'm gonna click this checkbox to use all of the fields in the person table, okay? And then I'm gonna click finish. And now we see it over here, data sources. I'm going to pin this. We can also click on Server Explorer and see that this is the database right here. And we see the person table here, and we can click on this person table. I'm in Server Explorer. Do a right click, and we can view the show table data. Looks like this. I'm going to pin this. And this is a database table. It's got some names in there and some phone numbers. And we can see the, if you right click on here, we can see the table definition. And this down here is the actual create table SQL statement that can be used to create the table. That's what was used to create the table. That's just for your info. All right, so that's that. And so let's go back to sort data sources here and click down on that. Click down on person. And if you click down on this arrow thing and data sources, we can see there's a couple of different ways that we can, a couple of different built-in form controls that are already there for us. One of them is this data grid view. So I'm just going to drag the data grid view over here. Let me see if I can do that. Oh, no, I select data grid view, and then I drag this over, and it just drags right over. And it puts all these adapters down here. So this is the data grid view. And, you know, we can run it. Let's run this thing. And here it is. You see, here's the data. And we got this toolbar up here, and we can like you know, add a new person, Joe Schmo 555-1212. And then when we click to a different row, it should automatically save it. You can click Save Data here. And so now we see this ID 10 is Joe Schmo. Great. And we can close this now, and we should be able to, it takes a while for it to actually store into here. It takes a little while to refresh. The reason it does is because when we use a data source, well, looks like there's an issue. When we use a data source, it actually pulls up the data into a temporary buffer location, and that way when your program is going to manipulate data, it's able to manipulate it very quickly. And then when you're done using the data, then it actually pushes it back out into the database itself. I'll have to take a look at this more to figure out why it is, but oftentimes the reason is because the connection gets broken right away. These connections don't stay open for long, and I'm suspicious that perhaps the reason it wasn't able to work is because is because the connection broke before it had a chance to update. But anyway, so that's quickly what a database looks like, how a database works. So let me go through a little bit of theory here today with these slides, and then after that we can next time we can put a little bit of this theory to practice. And so today you're going to learn a new language, database language called SQL. And what's nice about SQL is it's a language that it will be around for a long, long time. Visual Studio is going to change. C# is going to change. 10 years from now, you probably won't be writing code in C#. You may be, but you might. Good chance you won't be. There'll be new languages. Programming languages come and go, but SQL is always going to be here. And the reason for that is because there's not much more you can do. It's basically the different ways that you can write data into a table, and SQL is sort of based off of it's got its roots in relational algebra, and there's just only so much you can do, and there's not really too much you can improve. You can add functions, you can make fancier functions, but it's not like the difference between C# and Python, and C# and other languages that you may learn if you decide to become a programmer. So I'm just going to buzz through these slides here today, and then we can put some of this into practice next time. So databases. So we're going to learn about introduction to database management systems. We're going to learn about tables, rows, and columns, how to create a database in Visual Studio, which we just saw, data grid view, which you just saw, connecting an existing database using the details view controls. You can do that by doing details view looks like this. Put this down here. If we click here, switch over to details, and then copy this over, looks like this, see? So now when we run this, we page through it like this, see? So this is like one record at a time. Now, if there were 100 fields in this table, you know, I in some of the databases I use, they've just grown over the years, and I'm dealing with tables that have 150 fields, got a whole bunch of crap in there, crap I don't use anymore. But it's difficult to manage when we're doing it in what's called table view, this data grid view like this. So you know, one record at a time is often easier to deal with. So so let's go back to what we were looking at before. Data bound controls, all that means is that you have this data grid view or you have this details view, and those controls, those are called controls, as you know, they are bound. We have binded them to the table itself. So when you mess with the controls, it automatically messes with the table. If you mess with the table some other way, it's going to reflect it in the controls. So that's what that means. And then selecting data with an SQL select statement. We'll see what that is. Okay, database management system is software that manages large collections of data. It's designed to store, retrieve, and manipulate the data. And a C# application can interact with the database management system through, they call it a 3-layer manipulation. We've got the application, which is your program, and then we have a database management system, which in our case is Microsoft SQL. And then we have the data itself, which is stored in a file usually, but it's you never see this. It's stored in some kind of format that's easy for the database management system to manipulate and carry out its commands. So we see data stored in a database is organized into tables, and tables have rows and columns. So we've got rows here and columns here. Each table holds a collection of related data. In relational algebra terminology, this whole thing is called a relation. A table is a two-dimensional container made up of rows and columns, and a row is a complete set of information about a single item. So a column holds an individual piece of information about the item. So in this case, rows, the item is a person. The column is an attribute of the person. We've got two attributes here. We've got a name and a phone number. Uh, uh, Other terms are, this is a record. This can be a record. A field, you can call this a field. It's another term. There's a field. It's a name field and a phone field. In relational algebra terminology, this is called a tuple. A tuple, and tuples have attributes. Each row contains data about one person. So, if you know, when we talk about strongly typed, weakly typed, and all that, a database is the most strongly typed thing there is. There's no giving. It's not the same as a spreadsheet. A spreadsheet, you say, oh, I'll put the name here, but you can put anything in there, and the spreadsheet's not going to complain. You have a phone number here, but you put an email address, the spreadsheet's not going to complain. Databases will complain. That's sort of the idea. The databases are designed to do well to do just as well when you're dealing with massive amounts of data, like millions of records of data. Driver's license database at the state of Hawaii and all that kind of stuff, Social Security database, millions and millions of records, and integrity is of the utmost importance. That's why we use databases. And so the fields or the columns have types. There can be a bit. It can be a bit type, which it can only store true or false values. It's just like the corresponding C# data type would be a bool function. There's date time fields. We have decimal fields, same. We've got floating point fields for storing real numbers. In C#, those are double. We've got money. Not all databases have money. This one, Microsoft SQL has money. Decimal. The advantage of money fields, advantage of decimal fields, is you don't get that funny rounding error that you can get when you do a bunch of divisions by a bunch of different numbers, and you've got the problem converting from base 10 to base 2, and so there can be way in digits way to the right of the decimal point. You can end up with some kind of rounding errors, and with decimal numbers and money numbers, it's converted into base 10 first, and then the calculation is done. So you never have the rounding problem. So you never end up, with a few pennies left over or short because you have the rounding problem. Now we have string fields in C#, but we have all kinds of different kinds of string fields in SQL. We specify the number of digits of the string, and we also can have an nchar field was fixed length, which means if it's nchar 50, it's going to take up 50 spaces. If you're only using 45 of them, there's going to be spaces, okay, to make up the 50. Whereas varchar is variable length. So if you only need 45 spaces, 45 positions, it only uses 45. It can hold up to 50. Let's say n is 50. It can hold up to 50. But if you try to put more in there, it's going to truncate it off. It's not going to accept it. It'll just hack it off to hold 50. There's no forgiving. Database tables have a primary key. And what the primary key does is with that one field or that one column or that one attribute, it is unique to the row, which means if you want to talk about that row, you can just identify it by the key. For example, if we, oh, this doesn't have it. You'll notice in the table we were looking at before, in this table here, we have this person ID. And this person ID is simply, it's just an integer, but it's unique. So what's nice about it is if we want to talk about Jeff Jenkins, or we want to talk about 5557890, or we want to talk about any other attribute that Jeff Jenkins might have, all we have to do is talk about person ID number 5. Talk about person number 5 and oh, what's the name of person ID number 5? Oh, it's Jeff Jenkins. Oh, what's the name of or well, what's the phone number for person ID number 5? Well, that's 5557890. Okay, so that's the key, and there's a key, a key to, a key that is unique can be a primary key, or a key is defined, a candidate key is there's different keys. There's primary keys, referring to identify rows in the particular table that we're talking about. There's also foreign keys linked to other tables, and we'll get to that later. So in a so examples of primary keys in typical tables might be an employee ID number, could be a social security number. Everyone's got a unique social security number. Could be a unique invoice number. Could be a sales order number. At the University of Hawaii, we can use we used to use, back when I started at the University of Hawaii, back before a long time ago, our student IDs were our social security numbers, because everybody would have a unique social security number. That's privacy now. It's bad. You don't want to give out your social security number. And then what came along were our email addresses, and everyone's got a unique email address. That could be used as a key, and that's often used as a key. In fact, in La Lima, that's used as the key. Back when I started at the University of Hawaii back in 1988, not everybody had an email address. It's only the techies that had email addresses. It's only people that wanted an email address had an email address. But then they made everybody get an email address. But they decided to go with these 8-digit UHIDs now, and so everyone's got an 8-digit UHID. So that's what UH now uses as your key to you. But we could, in La Lima, for example, we use the email address. There are old people. There are old couples that share email addresses. And I manage a database for a large political party here in Hawaii, and there are a lot of old timer couples that share email addresses, and it's a real pain. You think you're sending an email to her, and he reads it, that kind of thing, or the other way around. Sometimes the data you want to store in a table does not contain any unique items that can be used as a primary key. Well, that's not entirely true, because if you don't allow duplicate records, then the entire record itself, all of the fields combined, can be the key. But that's relational database theory. In a practical sense, you want to have a key, and you want the key to be as few number of fields as possible, as few number of columns as possible. Ideally, just one column, Just one column is the key. Also, ideally, that one column does not represent anything else. Okay, it's just a number. Okay, it's just a string of something, and it's not anything else. It's not the social security number. It's not the email address. It's not anything that you would ever want to possibly change. You know, somebody might want to change their email address for whatever reason. Well, you change the email address, yeah, because they don't like their email address, or it's their last name and they got married, or whatever. Um, uh, you want the key to be, ideally the key is just a number, and that's all it is the key. That way you'll not, nobody ever cares what it is. No one ever cares to want to change it or anything else. And so you often create an identity column specifically to serve as the primary key. And in the phone numbers example that I showed you at the beginning of class, that number 1, 2, 3, 4, 5, that serves the purpose very nicely. You add in somebody else, add a new person, you just increment that number. It's the next one up, and that's the key for that new person. So we can call that the identity column. Identity columns typically contain integers. Each time a new row is added to the table, the database management system automatically assigns a unique value to the identity column. Identify. It's identity. It's identity. Now this is wrong. Creating a database in Visual Studio. There's several components. We've got a data source, which is the source of data with which the application will work. That's right here. No. Oh, data source. That's the database. Data adapter, which connects the data source and retrieves the data from the table in the data source. Then there's a data set, which gets a copy of the table from the data adapter and keeps that in memory, and this is what you work with. And then the binding source, which is a component that can connect the user interface, connects the controls directly to the data set. I think I spoke earlier, and I meant to call it a data set, not a data source. Anyway. We didn't do this earlier, but if we're going to create a database from scratch, we will first create the Windows form application, and then if we want to add a database to it, we add a new item and we add a service-based database here. And that's what makes this MDF file. So the default name is database one.mdf. So that's like if we want to create a new. Let me close this. If we want to create a new one, we do right-click, add new item, and we add a service-based database, MDF, database one.mdf. Let me. I want to. It didn't get added. All right. Let's continue. When you use Visual Studio to create an SQL Server database, it's created in the projects in the projects folder where the form1.cs file is. It's going to be put in over here, the Solution Explorer in right here. It's going to be put right in here. With the extension .mdf. And I showed you data grid view, the data grid view control. It's a data bound control. A data bound control is a user interface control that's connected to a data source. It automatically displays the data from the data source, and it can change the data. It's the simplest data bound control that can display the database table in a scrollable grid. It's also nice because when it works, you can add and delete data also and save it. And this is the code that's generated when you drag over and stick a data grid view onto the form. This is the binding code, which binds the data, binds it to the data source and all that, the data set. And this is what this code executes when the user clicks the Save button on the navigation bar. It applies changes that have been made to the data set. Maybe I forgot to click the Save button. The load event handler also is added to the form, with the fill method, which fills up the data grid view. You can also do this details view, which I showed you. It's a set of individual controls. This has got 4 of them, 1, 2, 3, 4. Data view controls. And it puts it in a single column, and of course you can adjust them, you can drag them around and stuff, so it looks different, looks nicer. It's rather than showing multiple rows at once, it lets you see the entire row at a time, and it's an alternative to data grid view for interacting with the database. Data grid view and details view may be customized. You can move them around. If you select the data grid view control or any of them, there's a smart tag, which is this little arrow deal at the upper right hand corner, and you click on that and this thing pops down, and you can see you can enable stuff, you can edit the columns, you can make the columns wider, you can you know, make it look nicer and all that. You can rearrange the controls. By default, the view controls are automatically bound in the following ways. The columns contain character data that are bound. Columns that contain character data are bound to text box controls. Numeric columns are also bound to text box controls. Bit columns, checkboxes, are automatically connected to checkboxes. And date-time columns are automatically bound to date-time picker controls. You can customize the type of control you want in the data source window. And to see that, you can, over here, here you notice it's got to be on, I think. No, it doesn't. This is the XSD file. Well, something's not working right now. Anyway, oh, here we go. So here's where you select data grid or details, but these individually you can select different, you know, controls like this. So you can drag these over individually. See, I think select column, mark up and down, and this thing. So that's sets the person ID and so on. See, they all have little data grid controls here. I mean, they all have little smart tags or whatever these things are called. So this one here is this thing. You saw this. Preview the data, it's queries. You can see the queries here. preview the data. You can add queries. This is the select statement. We'll see what all this means in a moment. So here it shows how we selected between details and grid view. Okay, selecting data with an SQL select statement. SQL is short for Structured Query Language, and it's a standard language for working with database management systems. This business with storing data in tables that are related to each other by keys and foreign keys, that didn't start up until like 1970. Okay, there's a guy named Cod. And before then, Cod worked for IBM. Before then, databases were all just mixed in with the program. Okay, you had kind of like the program that we wrote where we interface it to a file. So the program itself did all the interfacing to the file, and if you wanted to retrieve data or combine data or anything, it was up to the programmer, you, to write the code, basically from scratch. And COD had the bright idea of separating it from the program and coming up with a language like this that allowed you to do all the type of database functions that programmers would ever want to do, and separated it from the programming language itself. And so the select statement is how you get data out, how you display data out. So you use a select statement. Use a select statement to construct queries, and so a query is sent to the database management system, and then a record set comes back. A table comes back. It may be the whole table, but not all the rows, just some of the rows. It could be the whole table and all the rows, or it could be the whole table but only some of the columns, or it could be just some of the rows and some of the columns. And so the select statement will allow you to do that. So in this select statement here, we have a table called product, and all we want to do is see the descriptions. So this select statement here is going to display out one column of data, and it's all the descriptions for all the products. You're not going to see anything else. So you aren't going to see the product ID, you're not going to see the price or anything, you're just going to see the description field. And SQL is not case sensitive. In this chapter, SQL statements are part of the C# applications that you'll create. So this is the general format of it. You select columns, can be 1, 0 or more, or 1 or more from a table. So in this example here, we're selecting not only the description but the price from a product, from a table called product. If we want to select every column, then we can use an asterisk. So this thing is going to display out the entire product table. We can also tack on a where clause. A where clause. Looks like this. This selects all the products where the price of the product is greater than 20. Now, there's got to be a price field in there, and it's got to be a decimal field. It's got to be, or a money field. So this has to make sense. But so with this thing, since there's an asterisk there, you're going to see what the price column is. But you're only going to see the rows where the price is greater than 20. That's what this is here for. So this, in relational algebra terminology, this is called the restriction, because you're restricting the number of rows that comes back. And this is the projection. This projects all the fields. This only projects, this just projects 2 of the fields. There's other relational operators. These are relational operators. So there's greater than, there's less than, there's greater than or equal to, there's less than or equal to, there's equal to, and there's not equal to. Not equal to, it looks like this. It's a greater than followed by a less than. It's not, it doesn't recognize, exclamation point equal sign. It does it this way. So this is going to display out the product number and the price from the product table where the price is equal to exactly $28.95. This is going to display out the columns where the description is equal to denim jeans. There could be more than one, but we're only looking for the ones where the description is denim jeans. Sometimes there might be single quotes. You notice we use single quotes here as the delimiter. If there's a single quote in the field, we have to put two in a row. That often messes people up. So SQL keywords and clauses are not case sensitive. However, the string comparisons are. In Microsoft SQL, in MySQL, it's not, but in Microsoft SQL it is. So this here, selecting products where the description is equal to that, which is different than that, which is different than that. And but there are functions that you can use. So this one here is going to take the description field, make it lowercase, and seeing if when you make it lowercase, is it equal to this? Okay, so that's going to take care of all of them. That's going to take care of all of these variations because this is lowercase written, and this takes every single description and makes it lowercase. All right, there's this like, which is kind of similar to equal, except for two things. One is that I'm quite sure that this is not case sensitive. I'm quite sure this is not case sensitive. At least it's not in the SQL I use. But also there's this percent thing. This is like a wild card. So what this first one is going to do is it's going to select out all the products where there is the word shirt someplace in the description. Can be at the beginning, can be at the end, can be in the middle someplace. This one here is going to look for products where the description begins with CHINO, and then it can have anything after that. And this last one is going to be, it's going to look for products where the description ends in this word jeans. So it can have anything in the beginning, but it's at the end it's got to be JEANS. And we also have this underscore wildcard, which just represents a single character. So this is going to look for product number, where product number begins with a 2, and then there can be anything there. It's got to be a single character there. -0, and then there's a single character there. And then we have these logical operators too, and, or, not. And so it's just the word. It's the word and, or, and not. Looks like this. So this is you're looking for products in the range of $20 to $30. That's what this does. And here you can mix them up here it's the or operator where it's greater than $20, or it's the product number looks like that. And this is where you're looking for shirts, or no, you're looking for products that do not have the word shirt in the description, anywhere in the description. You can order, display them out in a particular order, the records that come back. This can order by price. You can also have this descending operator here, where this is going to order by price, but in descending order. So it's going to put the most expensive ones first, and the cheapest ones at the end, at the bottom. The table adapter queries. Table adapter query is an SQL statement that is stored in the table adapter and can be executed simply by calling a command. So this table adapter field, this would be an SQL statement which is designed specifically where when it's executed, it fills the whatever control is that this thing fills, and for example, a data grid view control. And so you write the SQL statement. That's what I showed you. I showed you the SQL statement in the application earlier, and that's the purpose of this. And so this is kind of where C# and SQL sort of connect to each other, and it's in these kinds of things, the table adapters. So here I showed you this. Here's an SQL statement which, if you look closely at select product number, description, units on hand, and the price from the product table. And when we look at the schema, this is the schema. We see that schema definition file. We see that below there's this product table adapter, and there's this fill and get data methods here that are used along with this SQL statement to fill these fields into the data grid view in this example. And you can add your own SQL queries. And there's also some functions that come along with it. So these functions usually go along with, they can either be used just like we see here, but what comes back is just one number. It doesn't come back with a bunch of rows. It comes back with one number in this case. So this is going to read up all of the rows in product, but it's going to compute the average price, and that's what you're going to see. That's what's going to come out. This is going to compute the sum of all the prices. This is going to find the minimum price. It's going to find the maximum price. This is all Excel stuff. You've seen this with Excel. This is going to count them up, see how many there are. This is going to count up the number of values in a specified column. This is going to count up the number of rows in the table. This is usually the same, come out the same. And this is how in C# how you have an SQL query in there, but you want your program to be able to specify some stuff. So you might want in your program to be able to take as an input some price value, and then from that you want to produce a table that has got all of the products that are less than that price value. And so you would write your SQL statement like this, and then you'd have another statement. You'd have another statement in your C# code that will insert the value in here. So it's like an assignment. You insert the value for ampersand price value, and then that completes this select statement, and then it executes and it returns back a data set that's got all the products where the price is less than this particular price value. So anyway, that's the introduction to SQL. It's a nice short introduction, and next time I'll come up with an assignment, probably out of chapter 11, to give us a little exposure to that. All right. Are there any questions? Okay. I will see you next time.